utilizing OpenCV for machine learning, and introduction to image vector representation. For instance, a picture measuring 20 by 20 pixels would produce a linear array with a size of 400 pixels. The feature set, consisting of a one-dimensional vector, is used as the input for the machine learning algorithm. Each pixel's intensity value corresponds to a specific feature. Although this is the most basic set of features we can produce, it may not be the most optimal, especially when dealing with larger images. In such cases, inputting too many features into a machine learning algorithm may result in ineffective processing. Our goal is to decrease the quantity of input characteristics that depict every picture. By doing so, the machine learning algorithm will be able to make more generalized predictions based on the input data. It is advantageous to carry out dimensionality reduction in a more technical manner, in order to convert the image data from a space with multiple dimensions to a space with fewer dimensions. A method of accomplishing this could involve utilizing feature extraction and representation methods, like histogram of oriented gradients, O, or bag of words, O, to compactly depict an image. This can effectively decrease the duplication in the feature set and diminish the amount of computational resources needed for processing. By utilizing the methods mentioned above to transform the image data into a feature vector, there is an additional benefit of increasing the resilience of the vectorized image against changes in lighting, size, and perspective. The method of histogram of oriented gradients. The histogram of oriented gradients is a method for extracting features that aims to depict the specific shape and appearance of objects within an image by mapping their edge orientations. To summarize, the HOG method carries out the following procedures when utilized on an image. A common pre-processing measure for preparing images before inputting them into a machine learning system is to transform them into a feature vector. Calculates the gradients of the image in the horizontal and vertical directions using a pre-width operator, for instance. After that, the gradient's magnitude and direction are calculated for each pixel present in the image. Split the picture into separate cells that do not overlap and have a set size. Then, calculate a histogram of the gradient for each cell. The histogram depiction of each image cell is more condensed and less susceptible to interference. The dimensions of the cell are usually determined based on the desired capture of the image's features. Combines the histograms of cells blocks to create single-dimensional feature vectors, followed by normalization. This enhances the strength of the descriptor in the face of changes in lighting. Once all feature vectors representing the blocks of cells are normalized, they are then combined to create a final feature vector representing the entire image. OpenCV's HOG implementation accepts various input arguments for each of the aforementioned stages, such as the minimum object size that can be detected is determined by the size of the window, win size. This tutorial will demonstrate the advantages of converting an image into a feature vector, which significantly improves efficiency. The size of the image features of interest is usually captured by the cell size. The issue of varying illumination is addressed by the block size, block size. The overlap of neighboring blocks is determined by the parameter block stride. The amount of histogram bins, n-bins, needed to represent gradients spanning from 0 to 180 degrees. We will now generate a HOG descriptors function, which will use the HOG technique to compute feature vectors for a group of images. It is crucial to understand that the way in which the images are reshaped in this function is specific to the dataset that will be utilized in the following tutorial. If a different dataset is used, it is essential to adjust this section of the code accordingly. The method of bag of words. This tutorial has introduced the BABU technique, which is used for modeling text using machine learning algorithms. Despite this, the same approach can be utilized in computer vision, where photographs are considered as visual terms that can be used to extract characteristics. When used in computer vision, the BABU technique is commonly known as the bag of visual words technique due to this reason. Basically, the BAU method involves these actions when used on an image. There are various methods that can be utilized to transform an image into a feature vector. Two highly favored techniques, often utilized in combination with various machine learning algorithms, include the histogram of oriented gradients and the bag of words techniques. The process of obtaining feature descriptors from an image involves utilizing algorithms like the Scale Invariant Feature Transform, SIFT, or Speed Up Robust Features, SURF. These algorithms aim to ensure that the extracted features are not affected by changes in intensity, scale, rotation, or affine variations. Creates code words using the feature descriptors, with each code word representing comparable image segments. A method for creating these code words is to utilize k-means clustering to combine related descriptors into clusters. The centers of these clusters would subsequently represent the visual words, with the number of clusters determining the size of the vocabulary. This process includes assigning a code word to each feature descriptor by mapping them to the closest cluster in the vocabulary. The code words are arranged into a histogram, which serves as a feature vector to represent the image. We can generate a custom function called bow descriptors to utilize SIFT with the bow method on a collection of images. It's crucial to keep in mind that the resizing of the images in this function is specific to the dataset that will be utilized in this tutorial. If a different dataset is used, it is essential to make adjustments to this section of the code. Putting the methods to trial. There is no universal technique that is considered the best for all situations. The selection of a technique for image data often involves conducting controlled experiments. In this instructional guide, we will demonstrate the use of the HOG method on the digits dataset found in OpenCV and the bow method on images from the CIFAR-10 dataset. In this tutorial, we will only focus on a limited number of images from these two datasets in order to decrease the amount of processing time needed. In this lesson, you will learn about two methods for representing images as vectors, the histogram of oriented gradients, O, and the bag of words, BOW techniques. However, the identical code can be effortlessly expanded to encompass the complete datasets. We will begin by accessing the datasets that we will use for our work. Remember that in this tutorial, we learned how to retrieve the pictures from each dataset. I have developed two Python scripts, the digits dataset and the CIFAR dataset, which consist of the necessary code for importing the digits and CIFAR-10 datasets. After that, we can continue by transferring the datasets to the HOG descriptors and bow descriptors functions, which were previously made in this tutorial. The full code listing appears as shown below. The output that is generated by the code provided above can be seen below. After considering our selected parameter values, it can be observed that the AG technique produces a feature vector size of 181 for every image. This indicates that every image is currently portrayed as points within an 81-dimensional field. The bag of words, bow method, produces 1 by 50 vectors for each image. The length of the vector is determined by the preferred number of clusters in the k-means algorithm, which is similar to the size of a vocabulary. What are the benefits of using HOG or bow for representing image vectors? Thus, it is evident that rather than merely flattening each image into a 1D vector, we have successfully condensed the representation of each image by utilizing the HOG and bow methods. Our following action will involve exploring the potential of this data by utilizing various machine learning algorithms. In the realm of machine learning algorithms, one commonly implements a data pre-processing procedure for image data. This step organizes the data in a format that is compatible with the algorithms. In order to utilize the ML module of OpenCV, the image data must be provided to the machine learning algorithms as feature vectors with the same length. A possible approach for organizing image information is to compress it into a singular vector with a size matching the total number of pixels